The indicator quick change tool holder. Indicators are the most commonly used tools in a machinist toolbox when operating a lathe. Whether checking run out at the chuck, run out at the end of a long part at the live center, or checking taper of said part, machinists use indicators pretty much every time they use the lathe. One common solution is to use a magnetically mountable arm, like the Noga seen here, to position the indicator wherever on the part you're interested in, or mount the magnetic indicator on the cross slide itself so you can control longitudinal and radial adjustment. I propose that a quicker solution might be to make a quick change tool post mounted indicator holder so that, like other cutting tools, you can pop them in and out of the quick change tool post, position them quickly and accurately as you see fit. You may notice that the indicator I'm using is not a Michitoyo or a Starrett, but rather from a company named Shars, which imports tools from Taiwan and sometimes China and rebrands it as their own. Historically, the Chinese have gotten a bad rap as well as the Taiwanese, but in recent years, their tools have gotten much better. They use the same CNC machines that everyone else does these days, so there's no reason why they can't put out good tools. Historically, people went to China to go for cheap, not good, so the Chinese delivered what they asked for. In more recent years, the Taiwanese tried to differentiate themselves by making higher quality stuff and charging more for it. The Chinese have recently followed suit. So Shars picks and chooses among the different manufacturers to find the best quality stuff they can get for the price. I have had really good luck with their tools. I'd like to do a showdown with this Shars indicator and my Michitoyo and a Fowler I have, see how they stand up. I predict pretty well. Starting machinists like myself, there's so many tools you have to buy that you can't afford to get even a basic set without spending a vast sum of money. Some people would say, save your money until you can afford to buy good stuff. But I think this actually qualifies as good, so I'll do a review in the future to see if that actually holds up. So on to my design. My indicator quick change tool holder is made out of 6160 aluminum. 6160 is one of the most common aluminum alloys on the market today. Developed in the 1930s, 6160 is highly machinable, weldable, and corrosion resistant. I could have opted for steel, but I chose aluminum for its lightness. You could even split materials and make the part that mounts in the quick change tool holder out of steel so that it wouldn't be damaged as much by tightening the screws, and make the part that the indicator mounts in out of aluminum to keep the weight down. That might be a good compromise, and perhaps I'll make that part in the future. Another feature that stands out even more is that my quick change tool holder indicator mount is made in two parts. I did this because I thought that at some point in the future it might be interesting to have an indicator holder that could be used in another test fixture. It also allows me to rebuild the quick change tool holder mounting part out of steel if the aluminum is not holding up well enough. However, the whole point of this project is to make an indicator mount that doesn't have to go in and out a lot. So I don't think that at this time this will be much of an issue. In addition, the material thickness between the two parts is different in my current design. This was done for several reasons, not the least of which is that although I have a CXA quick change tool post with 3/4 inch capacity, I suspect that most home hobbyists use AXA or BXA sized quick change tool posts which only have capacities of 1/2 and 5/8 of an inch. For this reason, I made the part that mounts in the quick change tool post only 1/2 an inch thick. The indicator itself needs to be mounted in 3/4 inch stock because 1/2 inch would not have allowed enough material to be left when I drilled the 3/8 inch hole to allow the shaft of the indicator to extend out of the business end of this tool. Also, this allowed for a deeper thread for the locking screw. This is aluminum after all. Still, I could have made the whole part out of 3/4 inch stock and milled out the mounting section to 1/2 inch, and that would have been a perfectly good design. However, in this go-around, I'm opting for flexibility. Another notable detail in this design is that all of the dimensions chosen were for the Shars 0 to 1 inch indicator. If your preference is a different manufacturer's indicator, adjust the dimensions accordingly. These drawings are available from the links provided in the description section below this video. So let's make some chips. The face mill I'm using here is a Schar's 2.5-inch APMT insert face mill. The inserts that I am using at the moment are for steel. I've ordered some for aluminum, but they haven't arrived yet. That's why you're getting the long, stringy mess there. Also, I'm taking a 100,000ths cut, which is probably a bit much for this. I still need to play around. The surface finish seems to be fine, actually, looking at it. Although it does turn up a bit of a burr on the edges. I mean, that's not unusual, but I think I can do better. The piece I'm working on now is the part that gets screwed down in the quick change tool post on the lathe. It'll be, final dimensions will be 3/4 by 1/2 inch. Sorry about the Lexan. My machine shop is in my garage, and the chips getting thrown everywhere make quite a mess, so I try and contain them a little bit. I'll have to find better camera placement in the future. Second cut, I think, was only 50,000, so I was trying to see if it would be a bit cleaner, and I did notice the chip breakers for the steel APMT inserts actually work just fine. And the surface finish was surprisingly good, considering. Another 50,000ths cut. I'm only cutting from one direction rather than going back and forth. One, to keep control of where the chips are going. And number two is I wanted to see, I'm playing with parameters, so I'm trying to find out whether or not there is a better direction or a worse direction, depth of cut, speed of cut, feed rate, that sort of thing. So yeah, so each time I'm cutting from the same direction while I vary those other parameters, because it does tend to cut differently depending on which direction you're going. I think just up ahead I start figuring out that maybe I should use some lube, because you'll find out in a few minutes that I am getting some aluminum welding on the parts, not on the parts, on the inserts in the face mill. Again, they're not inserts designed for aluminum, so they don't have like a zircon nitride coating on them. Lube does end up helping that quite a bit, as I recall. This is a 150,000ths cut, and it starts to bog my mill down a bit. 3 horsepower motor, but 2.5-inch cutters, so it's a bit of a torque arm, I guess. My mill is a brand new Acra, very nicely made mill. It's Acra's first Chinese product. They have most of their stuff made for them in factories in Taiwan. This one was made in China. The Chinese, again, are getting much better quality, so Acra finally was willing to put their name on a Chinese mill. The price was extremely reasonable. The sales staff was really helpful when I went to buy it here. I'm seeing now that I'm getting some aluminum welding on the inserts. Oh, I'm sorry. They weren't APMMT inserts. That was the new face mill I bought. These are triangular inserts. Also a Schar's face mill. I actually haven't tested out the APMT one yet. Mixed the two up. Sorry about that. The feeds I was doing before were relatively slow feed speed, but the RPM on the mill was set to 600, sort of on the low end of what the face mill, well, high end for steel, but low end of what the face mill could do. I bumped it up to 1200 RPM. I'm going to add some lube and take a light cut, see if I can improve surface finish, and it does. I never gave you a close-up of the face surface finish before, but it's much better this go around. You can tell the sound's different too. This is a 25 thousandths cut. These inserts on this face mill have a wiper. They instead of coming to the standard rounded point, they have a flat spot on them. Strangely enough, I still haven't heard back from Schar's on how to order that specific insert. All they sell is standard triangular inserts, you know, with varying corner radii. But this really smooth finish I get, I think it's due to the wiper on the inserts. So I decided I'm going to use lube every time at this point because of the welding of the aluminum on the inserts. Notice how small the chips are here too. Higher speed, lighter cut. Feed rate's actually a little bit faster. I only have an X-axis power feed. I was playing with that, trying to find a good combination. My understanding is for all cutting tools, the magic doesn't happen to get the feeds and speeds right for the particular material and the particular inserts you're using. I think I was reading on one of the manufacturer's websites, it might have been Sandvik, that was saying that probably 90% of users don't use the right speeds and feeds for the chip breakers and insert style they're using, combined with the material. I think it'd be really helpful if the manufacturers tried harder to make their sites understandable, and even more importantly, wouldn't it be amazing if the manufacturers had compatibility between all of their inserts and the naming conventions and the holders? I know there's some commonalities, but you tend to have to struggle, which doesn't seem reasonable to me. Time to flip it. That was the 1/2 inch thickness. Now we're going to do the 3/4 inch height. Going back down to 600 RPM, because I'm going to try some thick, deep cuts again. And I find that even with the deeper cuts and the slower RPMs, if you use lube, you get a much better surface finish, which I guess won't be any surprise to anybody. $150 thousandths cut. And I forgot the lube. Another bad habit I've gotten is not always checking to make sure the burr's off before I measure. Good way to be off a 4 to 10 thousandths if you're not careful. Hey, you can even see in this shot that there's still some aluminum adhesion on the cutter itself. Day late, dollar short, mister. Overall, I've got to say I've been really happy with this face mill. I've had this one for a little while. I've used it on steel, including with these inserts, and it performed really well on steel. I guess if you have the right insert for the material, things can work out. Last roughing pass. And this is going to be the final finishing pass for this part. I speeded up to 1200 RPM just because, and add some lube. By the way, when I get this part out, I've been deburring between passes, which you haven't seen. I've been deburring on my grinder using a Scotch-Brite deburring wheel, just very lightly touching the corners. Does an excellent job on aluminum. Also makes a really interesting contrast in the part between the surface finish and the edge finish, because the edge finish isn't shiny like the surface finish. So just around the very edge, there's like a little frosting, which is, I think it's kind of nice. It's kind of a weird optical illusion. With the camera mounted on the vise, it almost looks like the column's rotating. Now I'm jumping straight into cutting the length off, and I'm taking a pretty big bite. This is like a 100,000ths cut. This is a very different cutter. This cutter is actually designed for aluminum. It's a zirconium nitride coated mill cutter. It's making very nice little aluminum needles to fly all over the place. Still using lube just in case. It does tend to work better all around. I think it improves tool life. This is not a precise measurement, nor does it need to be. So we need about 54 off. And sort of an aesthetic angle, the zirconium nitride coating is really pretty. It's interesting, in this lighting it looks yellow. In actuality, in sunlight and daylight and 5,000 Kelvin light, it looks silver with only a slight yellow cast. Really pretty finish. That was a much lighter cut. Okay, on to the big piece where the indicator is going to be mounted in directly. Figured I'd trim the part to length since I already have the milling cutter in the mill. I was touching off to set my x-axis position. I ended up with a really big pile of these aluminum needles. Kind of pretty. I lowered the table. It's interesting because it was cutting fine, but it kind of looked like the top of the part was high up on the cutter, maybe even past the ends of the flutes, even though it wasn't cutting like it was. So I thought I'd get more in the meat of the cutter just to make sure. Interesting also, I'm not being careful. I'm not cutting on the backstroke because that would be climb milling, but it's interesting to note that the finish is really clean until you go backwards, and I think the reason for that is when you're going forwards, you're cutting big amounts of, well, relatively large amounts of aluminum, so you're loading up the cutter and you're deflecting it ever so slightly, maybe on the order of a couple 10,000ths. And then when you're going in the back cut, when you're feeding the other direction where it's not cutting out much meat, in that situation, there's very little load on the mill cutter, so there's almost no deflection. So now it's a little bit closer to the part, and that's why it puts this tiny little cuts in and actually ruins the finish. So this time I'm going to pull out. And the finish is beautiful. Very happy with the cutter. So I'm speeding up the next part of the video here, just so that there's not too much monotony. It will be funny though. You can look on the backstroke, see the ripples that the going backwards on the mill across the surface, the weird wavy pattern it puts in it. So I'm zipping through the trimming a little bit. And you can see the finish there is really nice. Until I ruin it. Final cut this side. Check out the finish after this. I think it's 25 thousandths cut. Actually, it was a little bit left because it was a finishing cut. I think it was 14. So I finally jumped ahead to the final pass on the second side, second long side. At the end of this, this is sped up quite a bit. At the end of this, check out the finish on it. Turns out really good. So accelerated time frame onto the last two finishing passes. Wait a minute. Oh, I guess we're done. Boy, when we're done, aren't we? All right. I think you should get to see how it turned out. Not bad. I mean, you wouldn't mistake it for a mirror or anything, but it's smooth to the touch. Can't feel any bumps at all. See you in part 2.